Hey everyone. Hi. What's up, you all? Welcome to GSW Global TV Hack Week January, which is Beginners Week today. And yay, I'm super excited. And I am Khushi Mahavar, your host for the session today. Before we talk about anything else, I want all of you to check in and register before and then check in through the OHQ link I'm going to drop in the chat box. And I believe my video is lagging for me. Is it lagging for you all too? Um, hey, Hustle 0786. Hi, what's up? Okay, first of all, I'll drop the OHQ link and you all can just go and check in. Let me find the link. Okay, here it is. I'll copy paste it here. It is lagging. Okay, is it my internet? Okay, I'll just check. Um, it's my college Wi-Fi. I don't know why it's lagging today. Is it still lagging? Mm, I can do it through my mobile data, but I'm sure it will not be better than this because it would get exhausted at the end, right? Um, okay, can I please get a comment letting me know if it's still lagging because it is happening for me, so I need to ensure and find the issue and resolve it somehow. Or otherwise, I'll just move on with the session, right? Okay, it's fine, right? Okay, never mind. So I would just request you all to please check in. Thank you, Hustle of 786. So those who are watching without registering in checking it's completely fine. But it would be better if you could take out a minute and just register and check in for the workshop, right? So I can wait for you all for just a minute. I'm here. So let's talk to the audience till you guys are checking in. So, how's the weather? I'm here in nearby New Delhi, and it's very cold here. And although it's a relief today that we had sun, so it's better. It's a relief. Although in the news it says it might get to a negative temperature some days. So let's see. So today, in this session of Introduction to Data Science, we are going to put some hands on data science today, and we'll try to analyze a data set in the session. So since this GSW is a beginner's hack week, we're going to focus on basics, and we'll see how we can get started with data science in our career or just build our interest in it, right? So before we get started, um, let me introduce myself. Audio is clear, only video is lagging. I don't know why it's happening. It just started. Although my internet is also working fine. I am not sure. Okay. Never mind. I hope it gets fine later. Okay, Hustle says it's same here. Today it's a sunny day. Yeah, right. And it's a good relief, right? So although my I hope my video won't disturb you all. I'll turn it off if it is disturbing. Um, okay, I hope it gets better in a few minutes. So, okay, let me introduce myself. Are the slides also not working? Okay, yeah. So, hey everyone, I am Khushi Mahavar and I'm an APAC coach at MLH. I use the pronouns she or her. So, there's this fact about me that I love being called by my last name, from my friends to my roommate to my teachers. Everyone calls me Mahavar. and there's a story behind it. So if you would like to call me by the name Mahavar, I am pretty cool about it. I like call being called by my last name. So, and the next fun fact about me is that I am living to eat food. I am a big food lover, and you'll see my love for food in today's data set. So, by this, you can guess that the data set we're going to analyze today is somewhat related to food, of course. Uh, um, the title is Major League Hacking. Okay. No, it says Introduction to Data Science here. I'm not sure what you're saying, Pavan. Okay. Yeah. Okay. And Hunain either says where I live, there is around 10 degrees Celsius, so it's cold. Okay, I understand. I understand. New Delhi is pretty cold as well. It's okay, Pavan. Never mind. Okay. So, yeah, that's all about me. So, let's not waste any more time and begin with something now. So let me state an example here. So we'll start about by talking about data. So we all often shop online, right? We look over clothes, try buying shoes, or just hover over stuff, looking, wishing to buy it someday. So, but whenever you actually buy something, you place an order. And what do? You log into the website, enter your name, your email ID, your contact number, then all of your details which are necessary over there. Then later, when you find your stuff, your product, you confirm the product, buy it by entering your address, your mobile number, your alternate mobile number sometimes, your PIN code, and then when you make the payment, you add your credit card or debit card details and CV, etc., etc. So that's a lot of data, right? So this is where the journey of data science begins from. This is where the story of data collection starts, right? So we talk about data science here. Wait, what is data science even, right? What? No, wait, what is data? Okay, so let's start from talking about data. So, okay, what is data? So, data is nothing but some discrete values, numbers, words. It can be even measurements, observation that convey some information, right? So as we talked about it in the online shopping example, all of that is something, some information or some data which is being collected. So how can data be collected for data analysis or modeling? It can be collected through making observations, recording them, through some research, through recording measurements or surveys or analysis, right? So in data science jobs, people get data from their clients who record all these data during their business periods. So this is how data can be recorded, and so data is a collection of raw information. Exactly. And then we process that raw information. We get the information, the processed information, right, from which we can actually convey something. Exactly. So data can be divided into two parts, which is, I guess, this must be some things which are known to you already: structured data and unstructured data. Structured data is, as by the name it sounds, it is something organized and it's pretty easy to work with. Unstructured data is unorganized, and you must organize it before you start analysis or modeling with it. So, due to lack of clear parameters, you need to structure the unstructured data, organize it, right? So, this can be done through data wrangling or data parsing. So, data wrangling, also called data munging, is nothing but transforming the raw or unstructured data into some format so that it's better for our understanding and our analysis. So, it turns out to be in an organized format, right? So, let me give you an example so that you can differentiate between what structured data is and unstructured data is. So we all use email, right? Email, Gmail, etc. From there we know that whenever you type a mail to someone, when you send a data or information, there is the timestamp gets noted and the date is sent along with the email. So this is something which is structured and can be easily understood versus the content of the email. If we talk about the content, is something which you need to extract in the meaning from, right? So the structured data, the date and email can be easily passed and stored in an organized format. But when we talk about the content you send inside the email, which is unstructured, you need to make more sense out of it so that you can store it exactly in an organized format. So we use some sophisticated techniques for that. So that is something we can talk about later. Right. So now, when we know about data, we can talk about data science. So, what is data science? So, as we have read, in from the childhood things, that data science is something is study of data. Simple science of data. As we say, biology is the study of life. Simple, but that is completely true. But this definition is quite small, quite near to explain the vast field of data science. Okay, let us have a look over this Venn diagram. So if you see here, this Venn diagram displays a lot of fields being involved in data science. So computer science, machine learning, statistical mathematics, business analytics, business problem solving, software development, and whatnot. And all of these fields are being integrated together to form data science, right? So this states that data science is a blend of various tools, various algorithms, and machine learning principles that make it the field of data science. So in layman terms, data science is nothing but obtaining meaningful information, extracting some meaningful information from the data set you have through analyzing, programming, and other business skills. So that is as simple as that, nothing very complicated. But when you work on data, you need to be very careful with what problem you are actually solving. Okay, so this will understand this in this slide, that how does data science actually work? How do you even play with the data you have? So okay, so here is a flow chart. Let me. Okay, here's a flowchart displaying some crucial steps involved in data science. So, first step here is problem statement. So, anything you do in life, anything right now, you are here or maybe looking at this video, there's must be some motivation behind it, right? So, anything you do, there's some motivation. So, data science is no different at all. There is always some motivation or some problem solving you are performing for data analysis. So before you directly jump on the analysis modeling stage, you need to study and analyze the problem properly. Many scientists consider this as the main and very important step of data science. So even when you get into the field of when you work as a data analyst, you get some data from your client or your data manager. There you have to study about the domain as well, about which the data is about, right? So once you research about the domain, you know what the domain is, you can then try to understand what problem you have to solve from that data. So even from that data, you and analyze it, get information. You have to conclude why that thing or has been happening. For example, if I say that in there I have a data of accidents, and it says that in winters there are more accidents happening. So why it has been happening? You have to conclude that and relate that with the real world. So if in winters it's happening, we can say it might be the fog which is causing accidents, because you cannot see clearly in fog, right? So this is how you would have to link it through the real world scenario. And then comes the data collection. So this is a very obvious step. Without data, you cannot even perform your modeling or analysis. So, so data can be collected, as we saw, through researches, through surveys, etc. And it might be in various forms like videos, spreadsheets, and so on. So, and then let's talk about data cleaning. Data cleaning, you might not have heard it, although it's pretty common now. So data cleaning sounds more like removing dust or dirt, right? So it's exactly like that. So data cleaning, the data you collect is not always need not always be in a perfect form, right? It might have some missing values, some redundant values, something which need to be processed before you start analyzing it. So data cleaning is all about the removal of those missing values, redundant values, unnecessary and duplicate data from your collection. So there are various tools to do so with the help of programming in either R or Python. So you can choose whichever language you want to work upon. So okay, let me have a look on the comments. Um, Hunain Haider says data can also be bought from Facebook, Google, Microsoft. Of course, that has been happening a lot, and that is some data privacy breach. So, right. So, this is something which is a part of data analysis as well. So this data gets used up for displaying advertisements to you. So when this data, for example, is sold to Facebook, Facebook displays you ads. So for example, if I search for something right now on the internet for shopping something, then Facebook would display me those kind of ads. And also Facebook stores your data, your age, your gender, and displays ads relevant to that. So this is something which has been happening in the industry nowadays. So yes, I was talking about data cleaning. So you can choose R or Python, any language which you find suitable. So Python is best for people who are beginning with data science, and then you can go ahead with R. R is said to be more better when you want to perform statistical analysis, because you have more packages, around 12,000 more packages in R. So once you know Python and you know how to work upon it, you can always move ahead and go with analyzing with our language. So then we have data analysis and exploration. This is the favorite part of mine. I love analyzing data after the all the steps we've studied about. And then in data analysis, it's the time to get your inner curiosity out. So it's all about analyzing the structure of data, finding hidden patterns in them, studying behaviors, visualizing the effects of one variable over others. And then we can conclude it according to the real life scenario, right? So we can explore the data and visualize it with the help of various graphs, which can be formed through libraries using any programming language. So in Python, we use Matplotlib and Seaborn, which is very common. And then it is data modeling. So data modeling comes once you're done with your study that you have formed from your data visualization. So you can build your model now. So model is built for predicting something in future. So for predicting something, you need to have a very good and accurate model. So here the term accuracy comes in the picture. So for this, for a greater accuracy, you must choose a good algorithm to fit your model at the best level. Right. So there are different kinds of algorithms, from regression to classification. So you must have heard of the word machine learning. Very common. And this is something which I'm talking about when I say data modeling here. So, right. So then we have optimization and deployment. So once you have built your model, you need to test your model as well, so that you know how accurate your model is and how well you can optimize it. So this is where optimization comes. You test your data and find how well it is performing by checking its accuracy. In short, you check the efficiency of data model and thus try to optimize it for better accurate prediction. Deployment deals with the launch of your model, and this lets the people outside um, um, uh, who can benefit from that. Right? You just deploy a model, and then people using the internet can just use a model and use it for their further analysis or something testing. It's very much like statistics, Hunain. So statistics is something which should be stronger when you choose this field of data science. So today we're gonna work upon um, some data set and try analyzing data. So since this is a beginners workshop, so I'll just look upon the first four steps, and will not move towards data modeling and optimization and deployment. So if you want to learn more of it, you can always look onto the LLH website and find some sessions which talk about deployment or machine learning. So we also have some beginner workshops regarding that. And today we'll stick towards data analysis and exploration. Okay. So I'll start presenting my screen and just give you a look of the data we're gonna work today on. Okay. I'll have to open our data. So, guess what kind of data it is? As I told, I'm a big foodie. I love food. So I chose the data of restaurants. That is Zomato. Zomato is an online food delivery app. So let's choose it. So let me open it so that you can get a glimpse of what exactly it is, what the data is, right? Okay. So this is a very huge Hmm. And I'm gonna use Jupyter Notebook here for it. Let me open it. You can use Google as well, otherwise Jupyter is fine. I use the prompt to open my Jupyter Notebook. Okay, let's. I guess it's my computer which is lagging today. I don't know what's happening. Even my laptop's fan was not working. I think I need to get it repaired. Okay, I just started the environment which I use on Jupyter. So this is done, and I'll just open my. You can also open your Jupyter Notebook through Anaconda Navigator. That is a GUI interface, and you can simply open the notebook from there. I use this often, so I open it from here. This will just open. Give me a minute. I think this is also taking time. Okay, never mind. This is what happens when your laptop gets old. It's loading. Excel. Hmm. What else can I stop right now? Okay. or at least this opened. Okay, let this open. So I had already created a notebook for you all. We'll type here the codes simultaneously, and you all can also open the notebook till then. And I'll just give you the link of the data set. The data set has been picked up from Kaggle, and I also used this same data set from one of my minor projects in my courses at college. So you can also do it someday, maybe. This is taking time. I don't know why. What's happening? File failed to load. Okay, it's working fine now. So let me just drop this link for you all. Let it be all destinations. So you all can go to this link. This is a Kaggle's link, and go and just download the data set. You'll get a zip file, and you can extract that zip file from there and use it for your data set analysis. So this data set is about an online food delivering app in India, which is Zomato. So it this data set is about Bangalore restaurants. Bangalore is an IT hub, and does there are a lot of people who are staying away from home there, and they, of course, people love food and they enjoy their cuisines from US to Japan, Russia to Antarctica, and so much more. So, in this data set, we'll analyze what factors involve in the running or establishment of restaurant. So, if this would just open, I'll give you a glimpse of data set, but it's taking time. Okay, we can wait till then. So from this data set has the data about the name of the restaurant, the location of the restaurant in Bangalore, what cuisines does the restaurant offer, and what else? It also tells what type of restaurant it is. Is it a buffet? Is it a cafe? Is it a pub? Is it a bar? Or etc. And it also tells if the or restaurant offers an online delivery, or does it offer a booking table option. So all these kind of variables are there in this data set. So we'll use this data set. There are two problem statements which I found that could be formed from this data set. That one from the perspective of a food lover or a food blogger. That person can analyze this data set and find which places are very popular in Bangalore, and which cuisines are popular in at which locations. And yeah, so this is something which can be done from this restaurant data set analysis. Another problem which can be formed is what um, kind of restaurant we can establish in which kind of location. So from we all know that restaurant business is also in a cutthroat competition right now. So every day another restaurant is opening, and it is getting very difficult to establish or run your own restaurant. So if you want to establish your own restaurant in Bangalore, you can analyze this data set and analyze which kind of cuisines people are loving, so that you can establish a restaurant of that particular cuisine. So this has got opened gratefully. So let's look at this. So we have this Zomato data set where we have a URL. I hope it's visible. Let me just have a check. It's Zomato leaked. Okay, it's not leaked. It was displayed on the website, and someone released the data set web scraping to analyze the data set. Right. So URL. In this data set, we have URL. the address of the restaurant, the name of the restaurant, and this online order variable tells that if the restaurant offers option of online delivery or not. So yes or no have been added here for each particular restaurant. Then there is a booking table, options for that location or cuisine, phone number of the restaurant, location, like cuisines, etc. So this is how you must have done. So now you know what problems of it by now, right? Oh, it's loading. Okay. Now it's visible. Let's come back to here. So now you know what problem we are gonna solve. We are gonna solve the problems for people who wanna establish restaurant, and we'll see what kind of restaurant they should establish at what kind of location, right? So let me also give you a glimpse of how the person would have collected this data. The This was the source, and in that data set, he or she told us that this data was accurate till 15th March 2019, and he scraped it from the Zomato website. So he scraped it in two phases. In phase one, he scraped the URL name and address of the restaurant, and from that particular URL, he opened each and every from each and every URL. He extracted information of the entire restaurant, which consisted of 15 variables. For each, these are those variables that we just saw, and you can imagine how difficult this can be. But programming can make it very easier. Web scraping is nothing but extracting information from HTML pages and storing it in some file like CSV file. So this can be done through programming, through Python, any language, right? Python is popular for web scraping. So this is how you must have done. So now you know how the data must have been collected as well. Now we can move forward about our data analysis. So, um, whenever we start our data analysis, we start by importing our libraries. So, also we will have to read our CSV file here before analyzing the data. So, we'll use pandas for reading our CSV file. So, I'm importing the required libraries from here. Okay, just give me a minute. Okay, everything's fine. I'll have to keep a check on this because I'm afraid if my laptop died somehow, then I'll be away from this live stream. My laptop's is killing me. Okay. Then we have which library? Import NumPy. We'll use NumPy here. And for visualization and plotting graphs, figures, we'll use Matplotlib Matplot module as PLD. Okay. Then we have, I'll also use Seaborn. So if you're familiar with Python, you must be knowing these libraries, and these are very easy to use. Nothing very difficult. If you know a little bit, even a little bit about them. Okay. Okay. Why am I making so many mistakes? Matplotlib. Fine. Hmm. Okay, how much time do you need, bro? Okay, so now we'll read the CSV file. So, before data can be analyzed, it must be imported, extracted. So we can import the data using pandas and Python, and we'll use read CSV function to import a CSV file. So let's create a data frame where we can store our file. So pd.read CSV. If you wish, you once you have downloaded the zip file and extracted it, you can start coding along with me if you wish, or otherwise you can just have a look and understand how it's happening. So here I had stored my folder, the file. So I just will copy its path Okay, I've copied its path and I'll put it inside these braces. So I have this path. So if you run this, you'll see you might get this error. You'll get so what happens is these slashes are being considered as escape characters. So the first backslash in a string is getting interpreted as a special character. So to fix this, we need to escape the backslashes in string. So we can do this by just doubling these backslashes. Another method is that you can add an R in front, or also to get rid of all this shit. You can just simply store the file in the same folder as your Jupyter notebook, and then just simply write so here's a matter.csv and import it. As simple as that. Um, I wish this could get run faster. I hope you're here with me. How long do you need, bro? Okay, I'm losing my patience. Okay, I'll have a water break meanwhile. You guys also have a water break. Stay hydrated. It's done. Okay. So now that you have read your CSV file, we can now just print the first 5 rows of the data frame, or you can even print the first 10 rows. Okay, if you want to print the first 10 rows of the data frame, just write 10 here. By default it prints just 5 rows. So here if you see 0 to ninth rows have been displayed here. So let's just keep it 5. Default is 5, so ultimately it will just display as the first 5 rows. So here, let us understand the data set. So if you see the URL of each and every data of restaurant has been provided, the address of the restaurant has been shown, the name of the restaurant that is Jalsa here. Online order says if it offers an online order facility. Book table shows that if it offers an booking table option as well. Then we have ratings. Ratings are, if you observe in these values, it is out of 0, out of 5, from and ranges from 0 to 5, right? And then we have votes for the restaurant, and then we have phone number of the restaurant, location of the restaurant in some area, and the rest type, if it's casual dining, is it cafe or some snack type restaurant. Then the dishes which have been liked a lot, cuisines which are offered in that restaurant. Then often we see that Zomato displays what cost is it, what cost would it, would it be for 2 people to order from that restaurant. Then we have reviews list. It states the entire reviews. Beautiful place, had been here for a dinner, etc., etc. Then we have menu item, which seems does not even have a data. Okay. Then we have listed in type, which tells the type of restaurant. Buffet restaurant. Okay. Then we have listed in city. Okay, there are two location here as well. Then the city. Okay. Okay, now that we have understood the data, we can go towards cleaning the data. So, did you observe that there were a lot of things which we do not actually need in this data? So, before moving towards that, let's have a look at the number of rows and columns. We should always know how large our data set is, right? So, let's just find the number of rows and columns. For that, we can use shape. So df, if you write df dot shape, you'll get the number of rows and columns. So here we have 51,717 rows in our columns and 17 variables. So variables, by variables I mean these variables, these features. So when you go in the modeling or machine learning study, you'll realize these variables are called features. So these are the variables I'm talking about. So we have 17 variables. So we can also list out all of these variables here by just writing df.columns. So df is a data frame. So here we have the variables we just talked about, right? Okay, you are all here with me. Then we have data cleaning. So if you would have observed, do you think we can extract any useful information from the URL? I don't think it's necessary for us. And since we already have location, do we need address of that restaurant? No, we don't, right? And then we have what else? Phone number. Is phone number necessary for our data analysis? No. What meaningful information would phone number provide? Nothing. Then menu item does not even have some data inside it. Let's why not drop um, these columns, right? So let's just drop these columns. Okay, so for dropping these, we can use the drop function, and I'll just write all the columns which we want to drop and just put all of these in quotes. And the first one was URL, which was not needed. Then it is address. Then we do not even need, what else do we not need? We do not need the phone number. It's not at all useful. And then I don't think we need reviews list. Reviews list would consist of string all the word reviews. So those are not actually helpful here. I guess the ratings are very helpful, right? So if you even want to build a model out of it, you know what you can do? You can look over the cuisines, look over the location of the restaurant, the type of restaurant, the name of the restaurant, and all these variables and the target variable. The target feature can be set as rating. So whenever you can build a model onto that, and then whenever you get a data, you get all these variables that are the location, the cuisines, type of restaurant, and from those variables you can predict what kind of rating that restaurant would get, right? So this is how you can build a model out of it. And modeling should always be done once you're done with analysis, but today we are just going to do the analysis, as I said. So okay, where were we? Right, so a reviews list, then menu item is not needed. What else was not needed? I think dish liked is also not very helpful because we already have cuisines here, right? So let's also drop this. Okay, so whenever you drop it, you write all the columns you drop, and if you're dropping it from the columns, you also need to mention the axis. If you're dropping the variables from the columns, you need to mention it as one. If you're dropping some data from rows, you need to mention it as zero, the axis. So now once I've written this command, I'll just print the first top rows as well. So you see here the URL has been removed, the address has been removed, and so on. So the columns you wanted to drop have been removed now. Now let's just drop the duplicates. And df drop duplicates. So drop duplicates is a function which is used for dropping the duplicate rows in a data frame. So in place true is used to update the data frame whenever uh, the duplicate is found. So I can also do it in this way, but to make it more easier, I can just simply write it like this, in place true. Okay. And then let's print the number of rows and columns again. Okay, okay, there is a change. If you observe, we had the total number of rows here as 51,717, and now we have it as 51,609, which means there were some duplicates, and since they were true, they were dropped, and the data frame was updated, and the df dot shape also got updated, right? So the number of rows have been reduced now. So let's rename the columns now. And for some reason they're different from the rating column values. There are ratings given in the reviews list column as well. Okay, Um, right. So sometimes data is not actually accurate even. So there is some bias in data as well, and that is very, difficult to remove. Rated 4.0. You're right. You're right. So maybe this is some average they have mentioned, isn't it? Um, Uptark. I'm not sure how to pronounce it. Right, Uptark. So never mind. We just dropped the column, so it's fine, and that was not very useful to us also. So let's move ahead. So if we find some column name which we find irrelevant or too long, we can always change it. So let's change the column name for this. This is too long. I don't like it. So let's just change it pf dot rename. Rename can be used to rename the columns or any of the data. So approx. No wait. I'll just rename all of the columns I want to. Approx cost for two people. Uh-huh. Let's rename it by cost. Two person, two plates. Fine. And then we also had listed in type, listed in type. Let's also rename it. Why? Let's just keep it simple. There was once when I had been given a data set to analyze, and there was a mistake in the spelling of a word. I also renamed that. So even my teacher laughed when he noticed that I had renamed that thing as well. So people thought I observed the data so much that I renamed the spellings too. So now you see it has been renamed. So this is easier to understand now rather than considering those long names. So now let's come to the real cleaning of data. So if you observe here in rate, it is okay. Let me just print those unique values. EF rate. So to print all the unique values in the column, you can just use this function unique. So here, if you see, okay, yeah. So here, if you see the values, for example, rating is 4.1. So don't get confused about rate as the price. It's rating. Okay. The first time I analyzed this data, I got confused. What kind of price is this for food? Then I realized it's rating, right? So this rating, if you observe, it's 4.1 upon 5, 3.8 upon 5, and then we also have new. Okay, then we also have a null value, NaN. Then we also have this slash, this dash, hash, dash, right? So, okay, we gotta remove this. We gotta remove this, and we also want to remove this because how would we analyze or how would we even extract information from this by using this upon 5? Nothing can be done. So we cannot even rearrange it in some manner because it's even the data type is object. So let's just convert it into float values and remove this upon 5. So I'm just creating a function where it will handle these ratings, and I'll pass this parameter which is value. And if value turns out to be new, or it turns out to be this dash. Where are you? Dash. Okay. And new, we need to put in this quotes. So if this turns out to be, then let's just return null values. What do you say? Let's just return a null value. And then if it isn't, then let's just convert it into float. So value, no, before we also need to, convert it into string and then split this 5. We do not want these 5 over here. So let's convert it into string and split it. Split it on what basis? On this. So once it's split, we'll just simply use the first um, value, that is the first index value, and then return this value in the form of float. Okay, as simple as that. And then let's apply this function to our rate column. So df rate, and then df rate dot apply. We're just updating the rate column by applying the handle rate function. I hope you're finding it easy. It's not very difficult. When you do it yourself, you will understand that it's very easy, and it's very fun to do, right? We can use a loop. We can make an array of unacceptable values and the loop, and then and the can loop over the data and using an if condition. Exactly, this can be done as well. But I guess this is easier. This is quite easier because it simply says that if you find any um, uh, unacceptable value, just return null, and then split it. If you do not find such kind of value, split this stupid fraction and return a float value. That is also an acceptable way. Yes, Sunain. So you guys are coming with different ways. I like that. So let's check now how many null values we have. You observe we had null values over here as well, and we have added some null values in place of these. So let's check how many null values we have created now. So to check null values, you can use is null and then dot sum. So okay, we have around 10,000 null values. What can we do? If we remove these null values, we'll lose 10,000 rows out of 50,000. That's quite a lot of rows, and we will not want to lose them. What can be done? Since we have these float values and we can take an average of mean out of it, why don't we just put a mean in those null values, right? So this is an acceptable way which can be done when you're dealing with mathematical values. So let's just put the fill na in null values. In place of null values, just fill mean of this column. This column, by this column I mean the rate column, and I'll write in place true so that the df gets updated automatically, and df dot, and now let's check the null values dot sum. Okay, so awesome. Now there are zero null values. So all the null values which had in all the null values in the rate column are now being been replaced by the mean values of this rate column. So now they have average values. This will not cause any problem. So whenever you're dealing with mathematical values, you can do this. But what about when you're dealing with string values? You cannot do anything. You will have to drop those, the entire, even if it's 10,000, you will have to drop all the rows, right? So now if you observe, let's okay, let me add a row here. Let's do an info check. So df.info allows you to give a full summary of the data frame. Now, if you see how many rows we had, do you remember? We had 51,609 rows. So name has this many non-null values, which is exactly the number of rows. So, okay. Now, if you see location has some null values. Rest type also does. Cuisines, cost to plates also have. So these four variables have some null values. So we cannot do anything about these null values, and these are not even much if you observe, right? So we even if they are, we cannot replace them by anything because we ourselves don't know the location. We cannot take an average of location and put it in the null values, right? That's meaningless. So we'll just drop all of these null values from the data frame. So to drop, Just write, use the data frame, then write drop NA. Drop NA will drop all the rows wherever null value is present for any column. Okay. Okay, I'll also write in place true. And let's then print our df dot head. So here the null values have been dropped. Okay. Um, okay. Why do we have these two? Okay, why that would be by mistake. Let me just remove this. I don't need you. So why two location specific columns? Okay, this was a question I came to. So I told you earlier as well, we were dealing with two location columns. Did you observe? We have this listed in city as well and location as well. Let us observe from, let us take 10. Why not 10? Okay, we have this 10. So, in Mysore Road location, we have the city Banashankari. In Basavanagudi, we have the city Banashankari. So it's okay. It's very simple. These are the city which have been listed, and under the location, the area has been listed. Right. So let's just use the area. Right. It would be more location specific. Let us not use the city. Also, let us look at what all location do we have. Unique values of location. Okay, these are a lot. And what all do we have for listed in city type? Listed in city. What was it in bracket? No. Okay. Dot unique. Okay, so it would be obviously less. So let us just drop this now. It would be easier for us. So I'm dropping it. How did we drop? We use the drop n. No, drop na was for null. We'll just drop it through this drop function and write the um, column we want to drop. Listed in city. And we'll also mention the access as you remember. So that the it knows where to drop it from the rows or the column. And you see it has been dropped. The last column has been dropped. Okay. So now let's see for the cost two plates. Let us just print the unique values for cost two plates column. You'll see something here. You'll observe. So df cost two plates dot unique. Okay, so these are the unique values which are under the cost to plates column. So if you observe these values, here the values which are greater than three digits have a comma in them, right? So these are these are although the data type is object, this is something from which we cannot analyze. We need to convert it into string, not string. We need to convert it into either integer or float values, right? To use it for our analysis. So how do we do it? We would again have to do something. We can replace this comma by nothing. Simple, not even a space. Okay, let's see. Let's create a function. Let's call it handle comma. Handle comma. Is the spelling fine? Okay. Value. String value. Now the value has been converted into string, and now let's check wherever the comma is present in the string. We'll just replace the comma value dot replace by nothing. By nothing, I mean I'll write just empty quotes here, right? And then this value has been returned as float. Okay. Else, let's write the else command as well. Else, simply return float. No use of replacing anything. And just let's just apply this function. Okay. Toss two plates dot apply handle comma, and let's just print. Where is it? I'll just copy paste. It's stupid to write again and again. Okay. Now, if you observe the values, let us take this value 1000. It was 1 comma 00. Now it has been converted into a float value, and now it's 1000, right? Dot. So I'm correct. So 1000 dot. So it has been created, converted into a float value, and that's fine. We cleaned this column by removing these comma, and now we can use this for our analysis. That would be easier to, for example, if you want to display a bar chart, it would be very easy to just simply give the data and plot the bar chart, right? So the rest, let's talk about the rest type column. The rest type column consisted of values such as quick bites, cafe, delivery, dessert, parlor, etc. So let us just check out this column as well. Rest type. Let us look at it. Its value counts. So value counts is a function which gives you the value of all the unique it gives a series of count of all the unique values. Let's run this. So if you see, quick bites has this number of restaurants, casual dining has this number of restaurants, and there are numerous type of restaurants, and the if you observe, the value is getting smaller and smaller as we go down. So why don't we put these smaller values in a same value. For example, let us name all the values under what, under 1000 as others. Why, it would be impossible for us to deal with all values. These must be around 90 or 100. So how would you deal with all these values? So it's better to put all the values which have less count in a same value, which can be named as others. Simple. I'm not sure if I'm speaking very clearly, but I am trying my best. So let us do this thing. This thing can be done. Right. Rest types will store this data frame into this variable rest types, and we'll store the value count in this value counts. Sending also. So this will store all the value. I'll just display it here. So this will rest types will store all the value counts for a different value of the rest type column. Then let's find out the rest type which have the count less than 1000. So rest types less than 1000. Let's name it like this. And then rest types 1000. So this will find us all the rest type values which have count less than 1000. Let's print and let's see. Rest types less than 1000. Okay. So if you see, beverage shop, bar, food court, sweet shop, these have lesser count values, and will put all these values inside same variable and will call it as others. Okay. So this is the best option you can do when you handling a lot of type of values. So just put all the small values in a variable others. Handle rest type parameter value, and if the value is present in rest type rest types less than 1000, then we'll just return others. Okay. And then just for else, just return the value. We'll apply the function on our column. Let's type. Okay, apply handle rest type. I'm thinking we'll just make our task easier because it's taking a lot of time. Now, if you see, Quick Bytes has the same count, okay. Then we have another value added, which is called others, and it has its own count, which is 9003. And this is nothing but the total of rest types, which were less than 1000. Okay. So I hope you get a glimpse of what was happening. And similarly, we're going to do it for location column because there are a lot of locations and we'll not be able to, analyze all of them. So to reduce them, we'll put the location which have lesser count in a variable others as similar as we did it for um, the other one. So we could take only the first value in rest type. That would be more specific. First value in rest type. First value in rest type. This value. And you're saying that we put all these in others. I didn't get you. If you could just retype. I'm loving it how you guys are, suggesting things. It's awesome. We always need to brainstorm and think how we can make things easier. So now you understand this is a little time taking, this cleaning thing. So I'll just I had created a copy of this notebook. I'll put the cleaning location column code here, right? So we can just jump to data visualization. That's more fun part. Please open, please. Okay. So I'll just show. I'll just let's just copy paste now. It will get easier. Okay, let me just show you how we're gonna do it for here, and I'll just copy paste the code here so we can jump on to the data visualization. So see here, we have a lot many values for location as well, lot many locations, and it's for some locations there are very less number of restaurants. See in Pina we have only one restaurant. Then what's the use of keeping it in our data? Let's just put all of these locations in one value, that is others, right? The same we did it for rest type. So it's the same way I'm doing it here. I have created another variable and storing all the locations which have a count less than 300. Then I've created a function, and if the value if is present in this variable, and then return others. Very simple. It's a very similar thing, and it's very boring to repeat it for each and every column. Right. So now if you observe, the others has been added, and it has around 4,954 count value. Okay. So this will not this will be nothing but make your task easier. So first, similarly, I'm gonna do it for cuisines as well. I'm not gonna type this code again and again. This is so boring. Okay. Very same thing. If you observe, these all cuisines have very less number of value. Why put them here? Let's just put them in one value now. So we're doing it again here, and the cuisines which have less than a count value of 100 will put them in others. Okay, right. Done for this as well. Okay, df dot head. If you want to do it, check out how our data set looks now. Cuisine now observed others has been added. Others has been added here. Okay. Now let us also see for the type column as well. I already know type column does not have very much value, so you need not clean it. So if you observe, it has very less number of values, so it's you need not do the others thing here at least. thank you type. Okay, so let's come to the best part of data analysis, that is the data visualization. So let's look at the count of restaurants in different location. Okay, that is the first thing we can do, and we'll be using matplotlib here um, to create a figure, and we'll define the figure size. Figure size is a parameter. Size. This parameter will define the size for the width and height of your figure in inches. So, okay, fine, fine. And I'll use Seaborn to plot my graph. So in Seaborn, there's this function called count plot, which will help you to, plot all the count of each unique value. So Seaborn's count plot method can be used to show the count of each observation. So what all observation do we have? We have the observations of the location column because we want to show the count of different locations. So okay, let's plot. Where are you? Oh, okay. If you observe, these locations which have been written here are being overwritten. So what we can do, let us just rotate. Let us rotate these values, these ticks by writing. Uh, when you want to rotate the y ticks, you can just write y ticks. When you want to rotate for x-axis, write x ticks and write an angle. I am just giving it 90 degree. You can also put it as 45. It will be also fine, I guess. Okay, I'll write plt.show as well. Plot.show. This will show us the figure simply, and okay, sound seems so much more organized. Okay, now from this graph, if I want to observe, I see BTM. This location has the highest number of restaurants. So, if I'm willing to open a new restaurant in Bangalore, I should not open it in BTM at least. So, because this location has a high level of competition. So, if I want to survive, I should not open a restaurant here. So, then we have after BTM, then this is others, so we can skip it. Then we have HSR and Koramangala fifth block. These locations also have a high number of restaurants. So if you see Richmond Road, Shantinagar, Old Airport Road, these are some locations which have lesser number of restaurants. So if I want to open a new restaurant, I might pick these locations which have less number of restaurants, because here I might have a chance to grow more, right? But I would also have to look towards the demographic of these locations. It might happen that these locations have lesser number of population, less number of people living here. That's why they have less number of restaurants, right? So I would have to look for the demographics as well to understand which location should be the best. Okay, but you got the clips. So then you remember we had a column named online order. So that online order had two values, yes or no, whether it offers an online order facility or not. So here we can just print how many number of restaurants are offering online facility and how many are not. Simple. So let me write the figure size. So figure. So you can check out more parameters for these this figure function. You can check out in the documentation. You can also change color of graphs as well here. We'll change. Let us just plot account plot for online order. Okay. Uh-huh. That's fine. Module Cborn has no. Oh my god, why am I making so many spelling mistakes? Count plot. Fine. Oh, here you are. So see, so Majority of restaurants, that is around 30,000 restaurants, are offering online order, while there are restaurants, 20,000 restaurants. There are a lot of restaurants which are not offering online order. So, if I want to establish a restaurant, I should offer an online order facility, because there is a majority of them offering already, and that means there is a demand of it, right? Oh, what happened? Is it something you guys missed? Okay, let me read the comments. It seems interesting. I meant we could take the first value in multiple valued rows. I meant we could take the first value in multiple. Okay, multiple valued rows. Hmm. I think I would have to keep a track of the comments while I'm saying these things, because now I'm not able to link what this says about. We're suggesting because we're enjoying. It's very fun and informative. That's awesome, Hunain. That's awesome. Uptark says most of the rows which have very low count are multiple val. Right, exactly. Now I know. Now I understood. Right. So, like one of the rest I value was cafe beverage, so we can just take cafe for that restaurant. Okay, that can be done. That can be done. Then we would have to split it accordingly. Here it is a comma, and we can split it from that comma. That could be done. But how can you say that we can just discard beverage and take cafe, right? It's difficult to say that. That's why. But that is a technique we can do. We can optimize it more and use that way, right? Okay. Oh, Tanzia was having Wi-Fi issues. It's okay. It's okay. That was happening with me too today. It's fine. If you would be still more specific than other, right? It is. It is up talk, right? It can be done. Okay. So have you guys already worked with data science or data analysis before, at least? Because you guys seem to have an understanding of it, so it might be okay. That's awesome. That's awesome, Aptak. So you might be getting what is happening, right? And I find data analysis a lot of fun, because you use your curiosity here and try to analyze a lot of things out of the data. So you bring your Sherlock Holmes here. So this is something fun. Okay. Um, huh. So we were moving towards the booking table. Now that we have seen that online order facility account number, so let's visualize the booking table facility as well. Let's see how many what restaurants are offering it. I'm not gonna type this again and again. Let us just copy paste it from here, and I'll just change the column name. What is it? Oh, book table. Okay. Oh, I see. There are very less number of restaurants that are offering booking table option. Okay. Hmm. That means this could be, interpreted in two ways. Either the demand for booking table option is very less, or not many of the restaurants want to offer a booking table option, right? So these questions, to understand these questions, we can, use some research, use some surveys, or we can ask the person for whom we are doing this data analysis. For example, we have a client who has given us this data to analyze it for his business problem. We can ask him, why is this happening that most of the restaurants do not offer booking table option? From that, we can interpret our results actually. So this is just some mathematical analysis we're doing. We do not really know the reason, right? So to understand the reason, we can study some research. Okay. So maybe we can also say maybe this was an old data. This was data from 2019, right? So at that time, it might be that people were not, restaurants might not be offering booking table option by then. Okay, this could be one other reason. So now let's visualize online order. So let's what are we doing now? We'll visualize the restaurants which are offering online order facility and the ratings they're getting, in respect to that. So we'll see that if the online order facility is present, does the rating change according to that? We'll do this thing. Okay, so for this I'm going to use box plot here. So box plot allows you to understand the median, the quartile ranges. You might be knowing percentile. Okay, so this is something which is dealt here. So again, figure size. Okay, 6 then SNS dot box plot. Let's plot the box plot. And I'll plot the online order on x-axis, and what did we have? Rating. Rate. Okay. And rate on y. Then the data is our data frame itself. Oh, I misspelled it. Wait from. Okay. Hmm. It is taking time. Okay. Why are you not running? Okay, here it is. So this is the value stating yes and no for online order. So the restaurants which have been offering an online order facility have a median. This line in between the box states the median, the average value. So it's actually the median, but it comes out nearby to average, so we can also state it as average. Okay, so this median value is around what, 3.7. It is also 3.7, but if you observe, the maximum value for online order facility has reached around 4.7, and but for the restaurant which have not offered online facility, the maximum value could only reach around 4.2. So there is a difference, and in distribution. So it can be concluded that if we offer an online order facility, we might get more better ratings. So we would have a more chance of existing in the competition. Okay, then we have let's similarly visualize it for booking table option. Okay, so I'll copy paste it and just change the column name. Online order, no online order, book table. Okay. Oh, I see a major difference here. Even the average, the median value has been shifted. So in booking table option, if you offer a booking table option, even the average value you would get for ratings would be 4.2. And but if you do not offer, it would be only around 3.6 or 3.7. So it would be better if you offer a booking table option. Okay, also we had seen that a majority of restaurants do not provide booking table option, so it would be a benefit, a plus point for us if we provide a booking table option, right? So this is how you can analyze and implement it in real life scenarios. So now let's visualize online order facility according to the location. So let's see how many restaurants in a particular location are offering online order facility and how many are not. Okay. So for this we use group by function. The group by does not group by is very easy. It just groups a few columns together, and you can display the data as per your use. So we'll also use pivot table here. Okay, I'll just group what all I need. I need location. I need online order because I'm going to use it for my visualization. Then what else do I need? I need the count of number of restaurants. So now for number of restaurants, let's use the count of name. Okay. So here I'll put this data frame and the new data frame I have created to a CSV file for my ease. and let's just name it at location online.csv, because it also consists of online values. Okay, then we have, I'll read this file. PD dot, we already have seen how do we read this. We use the read CSV function to read all the CSV files. I'll again write this location online dot CSV. Now, because this file has been stored itself in the same folder where the Jupyter notebook is, so I need not write the entire path as we did here. And we also double slashed it, if you remember. Okay, so we can just simply, where are you? Here, do this, and then I'm gonna use this pivot table. So if you're not familiar with pivot table, just wait a few minutes. Once I run this cell, you'll understand how is it working. I'll just write the, okay, what is the index? The index location, I want the index is nothing but this kind of serial number, if I say it in layman terms. And then I want the columns as online order value and fill value 0 aggregate function np dot sum ef1. Okay, now you see this table has been created. So here in the index, the location values have been displayed. So these are all the location we have used, and then we have others. So and in online order we have either yes, either no or yes, and the name count, the total number of restaurants have been displayed here under no and yes. Okay, I understand it might be a little complicated for you to understand because you might be using the group by function for the first time, right? Okay, let me, okay. I have taken statistics course in it, so it seems similar. Right, right. You might be using Python for data analysis already then, right? Every decision make changes the data, so it's fun to try to. Yes, I agree completely. Completely. Maybe restaurants with booking table options are rich. Maybe because often the restaurants. I agree because whenever you have a date or a couple is there, they would go to some rich and elegant restaurant and book a table there. Not 5-star restaurant maybe, not a simple dhaba type restaurant, street food or something, right? The book tables there and then they give them a higher rating. Right, I agree. That could be a reason. So that is how you would have to find the reason. Okay. So this is the pivot table. Now let's plot a graph where a graph will be plotted for all of these locations, indicating what number of restaurants offer online order facility and what do not. Okay. And we'll just plot the data frame. Let's mention the kind, bar plot, figure size. I'm mentioning the figure size because this bar plot would be huge and I need it to be small. Okay, you. Right. So if you observe, these two values are indicating yes or no, and here are all the locations, and here is the count. So again, since BTM has higher number of restaurants, so if you see the blue line indicates the means no online facility, and yellow line indicates yes. So if you see electronic city, it has lesser number of online facility restaurants, and but it has a large number of restaurants already in here, so I would not wish to open a restaurant here. Okay. Now, if you see Richmond Road, here it has a lot of restaurants which do not have an online facility in comparison to those who have. I might wish to open a restaurant here, or in Shivaji Nagar, it has a very less number of restaurants in comparison to others and has lesser number of online facility restaurants as well. So if I would want my restaurant to open somewhere and grow and survive in this competition, I might want to open Shivaji Nagar, right? And a restaurant with an online facility. So similarly, we can do it for booking table option as well. Um, okay, let me do it. So it's very simple. You just copy paste code and change the variables and the data frame. So sometimes the things get repetitive, and you can just simply copy paste. Software engineering is, I believe, all about copy pasting. If anybody of you is software doing software engineering, right? Booking table option and location. Let's rename it book table. Okay, location, book, table, index, no, column we want, book table. Okay, right, that's it. We have created a new data frame here now. Okay, fine. I think it's fine. So again, a new pivot table has been created, and now let's just plot it simply df2 dot plot, and the kind of bar plot. Bar plot. Let's again mention the figure size. Figure size, what was it? 15,8, no? Oh, yeah. Okay. Hmm. So for a similar index has been, legend has been used. So, okay, very less number of restaurants are offering booking table option in each and every location. So I would of course not want to open a restaurant offering a booking table option in BTM because it already has a lot of restaurants. I don't want to exist in this cutthroat competition. Already there is a lot of competition in life, a lot of struggle. So let us open it somewhere else which has lesser number of restaurants and has a greater number of restaurants which do not offer booking table options so that my restaurant will grow. So again, I see Shivaji Nagar is something which I find favorable, right? It has lesser number of restaurants and a greater number of restaurants which are not offering booking table option. So here I believe a restaurant, if it's established, can grow, right? um, we could compare number of votes and online order too. Number of votes and online order, right? Exactly, that could be done. We can see if restaurant with online order option have a higher number of customer. Hmm. Right, that could be done. I have not done that in my analysis, but that could be done. So this analysis thing, does not stop. You can always find some you can always group two variables, new variables, and find what analysis you can bring out. If there is lesser restaurants, maybe the demand there is exactly. So you need to check out, maybe it could be even the reason that the people living there are less. So you would have to check out the demographic as well to understand whether you should really open, yeah, a restaurant there. So if there are less people, why would you open a restaurant there? Because you would not get a lot of demand there, right? You not even you would lose the business, not even earn profit. Okay, so type of restaurant versus rate. So this is another thing which I've added. So let's visualize the type of restaurant. What type of restaurants did we have? We had that thing, dine out, buffet, delivery, etc. So let's plot them. Plot dot figure. Uh-huh. Fig size. Okay. Anything. I don't care about this. SNS. I'm plotting a box plot here. It would be easier for us to understand. So type. Okay. Remember, this is case sensitive. So I remember I changed it to capital T by P type. So I need to write it in that way. Rate. and data frame is df. Now let's change the color as well. I'm putting the palette. Palette is a parameter which you can use, and inferno or rainbow, anything you like. You can look out for the values of this parameter you can put and add into this. Okay. So, yeah, buffet, cafes, delivery, desserts type, dine out, drinks, and these were the values. Now let's see the median value. So buffet has a high median value. Okay, these have a lesser value. Drinks and nightlife and pubs and bars have a high median value. Hmm. I see the reason. That's an Bangalore is an IT hub, and people after their office might be going to the pubs and bars to enjoy. So that might be the reason that these areas are getting high rating in case of as compared to other types. So also the maximum rating in drinks and nightlife and pubs and bars has been around 4.9, and similarly for buffet. So if you want to open a restaurant, you might choose to open a drinks and nightlife or pubs and bars restaurant. Okay, you getting it? What do the lines in the boxes? Okay, so this line, the line inside the box plot, it indicates the median or the average value. Okay, so the average value for the rating in buffet type is around 4, and for example, for desserts type, the average or median rating has been around 3.7. And um these end this end and this end indicates the minimum value in buffet type rating, and this indicates the maximum rating. And these dots are the outliers. So delivery had a lot of outlier values where the outlier values range from even 2.0 to it also reached 3.0, and some of the outlier values also went up to 5. Okay. Min max value. It also includes the interquartile range. So the values lower than this includes the 25th percent quartile. If you understand the concept of percentile, you can. Okay. You can Google about this later more to understand exactly. So now we can also look in which location are people voting more for. So there was another thing Uptak mentioned. Where is it? Yeah, so number of votes and online order can be compared as well. Here I have compared location and on voting. Okay, so I'll group. I'll first create a data frame and just pick these two columns: location and what else was it? Votes. And okay, I'll drop some of the duplicates. Um. Okay. So here is our data frame, and now I'm gonna group it and create a new data frame. Whenever you group, you can create a new data frame. You can also update the same data frame, but it's better to group because you might be using the uh, old data frame again. So it's better to create a new data frame. Now I'm grouping those values. What was it? Location and location. Okay, location, and I want the sum of votes. Sum. Df5 equal to df5 dot frame, and I'll also sort the values, so it's easier to whenever. Okay, there's another thing I wanted to mention. Whenever you plot a bar graph, where is it? Try to sort the values. Okay, here it wasn't sorted, and once the values are sorted, you'll be able to easily realize which value has the higher count and which hasn't. Otherwise, you can also make it the orientation of this bar plot in horizontal way. You understand? The bar plots would be in this way. So it is because a study said that it's easier to read horizontal bar plots than vertical bar plots, because you observe our way of reading is left to right in general. So when we read left to right, it's easier for us to differentiate between two bar plots if they have a similar range. So if you see this HSR and what was this? Koramangala fifth block, we cannot differentiate the exact value. I'm pretty sure there would be must be a difference, but here we cannot. But if they were kind of in horizontal bar plot, it might be differentiated. Okay, that's how the human mind works. This was something I read in the study, so I wanted to pass on to you as well. Where were we? And okay. So, I was saying that make sure that you sort the value so that it's easier to identify which restaurant has a higher count. Votes sending TF5 dot head. Okay, okay. So the head showed us the top five row values. Okay, so I'll add a new column here. Now let's plot. Dot figure, fig size, 15.8 as we used it earlier. And I'm using a Seaborn bar plot and tf5 dot index and tf5 votes column. Then I'll since I have performed this analysis before, I know this these labels would get overwritten there, so I'll just rotate it already. Rotation 90. Plot dot show. Okay. So here you see we were comparing the votes as per location. So Koramangala fifth block has got the highest number of votes. So there must be some reason. Maybe the cuisine served in Koramangala fifth block are very awesome, or maybe the ambience of the restaurants is very good, or maybe the type of restaurants are more popular there, right? So these locations, the first, the topmost locations are getting more number of votes. So I might choose I might want to choose something, some location from the topmost, so that my restaurant also gets highest number of votes. But you remember we were talking about Shivaji Nagar. It has got the least number of votes. So I believe Shivaji Nagar, less number of restaurant has a reason, and that's why it's getting less number of votes. So I would prefer opening a restaurant from a location which is somewhere here. Okay. Or there are higher number of restaurants okay, that's the thing we were talking about earlier, right? So let's visualize the top cuisines. This is interesting. This is something you'll find some interesting thing here. So I'm again, it's the same thing now. I'll just copy paste and change the columns. Sometimes when I performed this data analysis for my mini project, I was not very familiar with data analysis. So it's very fine to Google and understand how you can, for example, if you want to group by columns, how you can group by. Google always, if you do not get how you can display and group by the columns. Okay. So I'll just rename these cuisines according to votes. Cuisines group by cuisines. Some I already wanted. Votes sort. And I also want to rename it. Let's rename. I'm storing it in another data frame.
Are we short of time? Okay, we have 15 minutes more. 6. And this is 7. Okay. No, this must be 7 because we're sorting the values of this. Uh-huh. And we have grouped this value. Now we are sorting it. Okay, fine. Name D7, TF7, T7. Okay, TF7. Huh. Okay, it's fine. So we see the others cuisines has a higher number of votes. Okay, that's irrelevant to us. The North Indian cuisine has the highest number of votes. Do you realize that Bangalore lies in the southern region of India, and their North Indian food has highest number of votes? So that is something strange you observe here. And so to find the conclusion, I might say, like in North India, South Indian food is quite popular. Even when I go for dinner with my family, my father always orders South Indian food, right? So this is something maybe um, uh, like so it might be a crazy thing that people are liking North Indian food in South India. So it might be something popular. Maybe North Indians are living there in more number. That's why they're eating North Indian food and voting it more, right? North Indian people who live are always eager for, right. That is something that could be a reason. Okay, so this can be found out through some research or surveys. The exact reason. So now I am gonna plot this, but do you observe that I do not want others here? So others is something irrelevant because I cannot conclude from it. So I'll just exclude it by locating only the columns which I need. So I'll locate and I'll begin it from 1. This starts from 0. I'm not including it and I'm beginning it from 1 to the end. So I'll not type any value here and it will include to the end. You should have used square braces. And let me just check out now. Yeah, now so others is removed. I'll just simply plot it now. Plot dot figure. Fig size 15 comma 8. Oh, this is boring now. It is interesting when you have to link it with the real life. So it gets interesting over there for me. Index EF7 folds. It is more interesting when you work in machine learning field when you have to build a model, right? So there you have to predict. We can use this data, this Zomato data set only to predict the rating of a newly built restaurant. So that can be done, and we can tell whether the restaurant would survive in certain years or not. Fixed size not defined. Okay, is has it been plotted? Okay. So here we have plotted as we had seen in this thing. So North Indian has the highest number of votes. Then we have North Indian, comma Chinese. Then South Indian is also in the race. So it is not somewhere behind. It is also in the topmost three values. Then we also have Chinese, North Indian, Mughlai, Cafe. So these are all other cuisines. Oh, my pizza is so behind. Pizza is something I love. And what else do we have? Hmm. Fast food, ice cream. Okay, this would make me crave for some things. So now we know that if you want to open a restaurant, we might choose to open a North Indian restaurant because this is something I can conclude that a lot of North Indians are living there because Bangalore is an IT hub, so a lot of people are working there. They might be North Indians, and therefore they're like North Indian food. So if I want to open a restaurant, I might want to open it in I might want to offer North Indian cuisines for them. So this is something, a summary I wrote. Let us just have a look over there. So North Indian, Chinese, followed by South Indian. These are the cuisines, most popular cuisines. Quick bites, casual dining, and cafe. These were the three most common type of restaurant. These are common, okay. So then we have most popular locations medium. So if I'm a foodie or if I'm a food blogger, I might want to go to these locations. So from the food blogger's perspective, he or she would want to go to the most popular location in Bangalore to eat some yummy food, right? So most of the restaurants do not offer table booking, as we saw. Most of them offered food delivery. So this should be, whenever we want to open a restaurant, we must offer food delivery option, because already a lot of restaurants are offering it. So the restaurant provide table booking service are expensive. Okay, did you observe this? This was something we were discussing in the chat box, right? Okay, that booking services, restaurants might be five-star restaurants or something, and that's why there are less, and not all restaurants are offering it, right? So this might be a reason. And cafe, pub, bars are rated higher than any other type of restaurants. So to achieve a higher rating, you might want to open a pub or a bar restaurant, right? So these were some conclusions we could make from our data analysis. Now, if we had wanted to work this for a client, we can now produce all these results to the client and ask him the reasons of this kind of data. Why have we received this kind of data, right? So I hope you all got a glimpse of how you can perform a data analysis. This was something, we could have performed more analysis into this, as we were discussing. Uptalk mentioned a few, and we all were discussing different ways as well, in which we can create functions and clean the data. Okay, so I hope you all enjoyed this, right? So data science is not just about data analysis. It also includes data modeling, optimization, and deployment. So to further understand it, you can always search for these workshops in MLH, and there might be other coaches who might be delivering this workshop today, or maybe have delivered it earlier. So right, so I'll be signing off here now. Okay, I hope it was enjoyable for you all. So okay, bye bye guys. Yes, you sure should, always try exploring and find new ways to explore data.